Hello everybody, this is Mr. McNair, and this is going to be a brief lesson on 4.1, identifying linear functions. Alright, this first problem we have up here says identify whether the graph represents a function, explain if the graph does represent a function, is the function linear. Alright, so first thing, when you're deciding whether a graph is a function or not, you want to look at the vertical line test. The vertical line test says if I could draw a vertical line anywhere on the graph and it only cross one time, then it is a function. Well, as we see, this graph right here, no matter where I put this vertical line, it will only cross once. So it is a function. And we can tell if a graph is a function, we can tell if a function is linear simply by looking at the graph and telling whether or not it's a straight line. And this graph is a straight line, so it is also linear. Okay? Here we're going to do the same thing. This graph, it passes the vertical line test because every vertical line you can draw here would only cross through it one time, so it is a function. Now looking at whether or not it's linear, does the graph make a straight line? No, so this is not linear. Alright, and this next one here, does this graph pass the vertical line test? Well, here we see that it doesn't, because that vertical line will hit the other vertical line infinitely many times. So this is not a function. But is it linear? Yes, it's a line, so therefore it is linear. Alright, great. Tell whether the given ordered pairs satisfy a linear function and explain. Now, one way that you'll be able to tell from a table if something is a linear function is by looking and seeing if there's a consistent change in the x values that corresponds to a consistent change in the y values. Well, let's look at the change in the x values. Here we went down 1, here we went down 1, here we went down 1, and here we went down 1. So there's a constant change in x. Now, does that correspond to a constant change in y? Well, here we went up 2, here we went up 2, here we went up 2, here we went up 2. So, is this a linear function? Yes. And you would say because a constant change in x corresponds to a constant change in y. Okay. Constant change in x corresponds to a constant change in y. There we go. Alright, let's try another one. Let's just move that over here. Alright. Again, we have another table. So let's look at the change in the x values. Here, we went up by 3. Here, we went up by 5. Here, we went up by 7. And then here we went up by 9. So automatically we see that there's not a constant change in x, even though there is a constant change in the y. So this is not a linear function. Okay? Great. Here, tell whether the given ordered pairs satisfy a linear function. Explain. This one is very similar to the last one, except they give you all the information as ordered pairs instead of as a table. So what I would suggest that you do is actually go ahead and make a table out of the ordered pairs. Here, we see what all the x values are. 0, -2, -4, -6, and -8. So we'll go ahead and just put those in their positions in the table. 0, -2, -4, -6, and -8. And then the corresponding y values are 5, 3, 1, -1, and -3. Alright, let's take a look and see how the x's change. Here we went down 2, here down 2, here down 2, and then here we went down 2. And then over here on the y values, we went down 2, went down 2, went down 2, and then went down 2 again. So this is a linear function because there's a constant change in the x. that corresponds to a constant change in the y. Now, please, once again, don't get confused. The values that change, the constant change in the x doesn't have to be the same constant change as the y. Here, it just happens to be. Okay? So, other characteristics of a linear equation. X and y both have exponents of 1. X and y are not multiplied together, and x and y do not appear in denominators, exponents, or radical signs. So, this first problem that we have down here, 2x plus 3y equals 5, is it linear? Well, this one meets all of those stipulations. So, yes, this one is linear. All right. 2y equals 8. Once again, this meets all of the stipulations. So this one is also linear. Now this one gives people a problem simply because there's no x value. But there doesn't have to be an x and a y for something to be a linear equation. All it has to have is one of those. Okay? This one is not linear. And it's not linear because we have an exponent of 2 there. Okay? And then this one here, this one is linear. Alright? This one throws people off simply because a lot of times people look and say, well, there's fractions involved. Well, there can be fractions. They just can't appear in the denominator of a fraction. And denominator, remember, is the bottom of the fraction. Okay. Now, it also said graph the linear ones. We're not going to do that on this video because we've actually done that before. So if you need help with the graphs, just let me know. All you're really going to do when you're graphing a function is you're going to make a table of values, solve for y, and we'll go from there. In fact, let's go ahead and do one that we graph. It would look like this. Find 3 ordered pairs that are solutions to the equation, then graph the linear function. So whenever you're graphing a linear function, the first thing that I would suggest you do is to solve for y. So let's do that first. Let's get y by itself. So to get y alone, we need to move the 3 and the negative 2x. You always move the one that is not attached to it. So we're going to move this negative 2x first. Always get rid of addition and subtraction first. Now whenever you move a variable from one side to the other, it's always going to be through addition or subtraction. So to get rid of a negative 2x, we add 2x. So these cancel out, leaving you with 3y equals 2x plus 15. Oh, excuse me. That's minus 15. And then we're going to divide everything by 3. So we get y equals 2 divided by 3 is just 2/3. And I want you to keep that as a simplified fraction. And negative 15 divided by 3 is negative 5. From there, we can go ahead and pick some values. Let's see. Values that I would pick, because we have a fraction involved here, I would suggest that you pick multiples of the denominator. And we talked about that in class. Because multiples of the denominator would help you to come out with whole numbers, okay, or excuse me, integers. So let's pick some values. Let's go ahead and use 0, 3, and 6, for example. All right, if you plug in 0 here, 2/3 of 0 is 0. 0 minus 5 is negative 5. 2/3 of 3, that's 2. 2 minus 5 is negative 3. And 2/3 of 6, that's 4. 4 minus 5 is negative 1. So we can go ahead and plot those values. 0, negative 5 would be here. 3, negative 3 would be here. And 6, negative 1 would be here. All right, and then from there, you're going to go ahead and connect the dots with a straight line. And there we go. We found 3 ordered pairs that are solutions. Here's the 3 ordered pairs right here. And then we use those 3 ordered pairs to graph the function. All right. Hope this video has been helpful to you, and have a great day.